All right, folks. I'm recording this sort of example from section 2.4 of the text, and it's an example of a stem and leaf diagram. All right. So the reason I'm going to record this is my Tuesday Thursday class. Where we're a little pressed for time towards the end. So a couple folks I know logged off before I got a chance to explain this. What I did at that point was bring up the ebook. This is page 62 in the ebook, or the textbook, if you're looking in that. And I kind of talked my way through it, but let me slow down a little bit here, kind of work it out as I go on the board, and then talk about maybe some variations that we could do. Alrighty. So first of all, I've got this table over here of data, right? So let me just double check what this data was supposed to represent. This is table 2.13, they call it, cholesterol levels for 20 high-level patients. So some doctors checked 20 people's cholesterol levels, and this is the data they got. So we've got 1, 2, 3, 4, 5 rows, 4 columns, 20 pieces of data. So a stem and leaf graph is it's a way of organizing our data. It's similar in a sense. It kind of combines a little bit of what we saw with the dot plot, and it also sort of combines a little bit of the idea of a histogram, where a histogram, the height of the bar compared to other bars, kind of told us how frequent the relative frequency of that bar compared to a smaller one. And so we're going to see something similar with the stem and leaf and sort of the length of these leaves that we attach onto here. Okay. So the concept here is stem and leaf. It's pretty much going to contain all the information, all the numerical information that's contained here, except in a little bit more of a concise way. All right. So let me give an example. Let me grab another color marker here. And let's look at all the numbers in the range or the class of, let's say, 200 up to 209. So essentially what we're doing with stem and leaf is we're breaking things into classes. So I can have 200 to 209. I can have 210 up to 219, right? Can be another class. And I can do 220 up to maybe 229. All right. And then I can do a fourth class. Let me get all these set up of, let's say, 190 to 199. Okay. And so this right here, this would be a limit grouping what I did here, because I've got the upper bound. So this is for discrete data. In other words, we're not considering values between 199 and 200. So this is my lower limit and my upper limit for that class. My lower limit, upper limit, and so forth. So I've got 4 classes here, and all of them have the same width. They all include 10 values. So let's say from 210, 211, 212, 213, 214, 215, 216, 217, 218, 219, right? So I've got 10 values in there. So they've all got the same width. And these are appropriate for this data. I don't have anything larger than 230, so I don't need to go to the next class. I don't have anything in the 180s or less. So there we go. So you could just do a frequency table and start doing some tallies. So if I made a frequency table out of this, I would lose track of what values were in there. So in other words, if I look for values from 190 to 199, I see one of them, right? So I could, let me get my black pen back, do a 1. If I want to do 200 to 209, I see 1, 2, 3, 4, 5, 6, 7, right? So 1, 2, 3, 4, 5, 6, 7. That's what we did earlier with the frequencies. So just counting them up. However, now that I know that there's 7 pieces of data in this class, but I don't know where they live in that class, right? I've lost, by doing this, I've lost the detail contained in the actual numbers, right? In other words, 200, that's in that class, but it's pretty low, right? 209, do I have any 209s? I have a 208 is in that class. It's a little bit higher, right? So maybe we want a way of distinguishing those things. So again, the dot plot was you could do a dot plot for this. If you were doing that, just to sort of include that here, because I didn't really do one on the board, you would want to include at least your lower number or something like that. So here I could do 190, and then I could do 200, and then I could do 210, and I could do 220, and I could do 230. So make sure I've got my ranges in there. And so the dot plot in the book had 10 little segments per spot. So I'm splitting it in 5 and then splitting it up. So you could do something like that. And There we go. I won't do the rest for now. And then, so how did the dot plot work? You just put a dot. So here, 200, I would put a dot right there, right? Who came up a couple times? 210, 210, 210. So I would have 1, 2, at least 3 dots, unless that comes up another time, right? So that was kind of the idea of a dot plot. So I would have 20 dots spread out, plotted on this graph, based on those 20 bits of information. And so the dot plot was helpful. It tells me sort of how many are there, and so I won't do all of this because it would be time consuming. But maybe as an exercise for yourself, you want to build a dot plot based on this data and see what it looks like. Okay, so that's kind of the idea, and so that captures a little bit more than just what range we're in and using tally marks, because I see exactly 3 of a certain value and so forth. So dot plot was cool. Stem and leaf. So to me, that's a fun name. Basically, if I've got a number like 214, this is the leaf, right? And this is the stem. And with any number, no matter how long your number is, the very last digit, the rightmost digit is what the textbook says, is the leaf. Everything else is the stem. So if you've got 8675309 as a number, your leaf is the number 9, and your stem is 8675330, right? So so the stem is as long as necessary. The leaf is always that very last digit. Okay, so what's the point of all this? Well, the stem and leaf diagram is going to show, it's going to capture all of this information. I'm not going to lose any information from this thing. I'm just going to write it a little bit more concisely. So let's think of the classes that I erased earlier. There's some things that have a stem. See this 19? That's my stem. So I've got a 19 right there. I've got a stem that looks like 20, right? Some numbers start with 20. I've got a stem that looks like 21. And then I've got, do I have any stems? I've got a stem that looks like 22. All right. And then I didn't have anything higher. There's nothing in the 230 range here, so I don't have any 23s. Nothing in the 18 range and the 180s. I didn't have any of those. So what I want to do now is set up a little T-table, let's say. They call this in the book a vertical rule. Let me buy myself a little bit more space there. A vertical rule, just a vertical line that you draw with a ruler is why they're calling it that. And let me list my stems in increasing order as I go down. All right. So I have some numbers that begin with 19. I have some numbers that begin with 20. I have some numbers that begin with 21. And I have some numbers that begin with 22. Okay, so we do that. We list our stems. And then what I'm going to do, in the book they do this a 2-step process. So maybe I'll list them, I'll brainstorm them over here. What we want to do now is list all the single digits, all the leaves that fall into this category, that live in that class. But we're told to list them in increasing order. All right. In my class yesterday, I was separating them with commas. I noticed in the book today they don't use commas. I'll probably use them here just for clarity, but you know, you do what WebAssign or what Pearson wants you to do. So let me go through this first of all. So let me look at all the data and how many of these numbers, all these 3-digit numbers, which ones of them start with a 19. And so I can kind of circle these if I want to, but I see that number there, and that's the only one that starts with a 19. So there's not much to do here. Put the 9 right there. Okay. So there we go. So 199, that's the number. 199, that's that number. We're just splitting it up into its stem and its leaf. So at this point still you might be saying, why? Why did we do that? Well, let's look at all the numbers that are in the 200 range. So let me circle those in my table here. So I see 1, 2, 3, 4, 5, 6, and 7. And I'll take another look to double check. These will have a 1 there, 2. I think I got them all. So there's 7 of them. So you can probably get those in order as you go, but let me just write all the numbers down here. So here I see an 8, right, and a 2. So I'm going to go through this in sort of a methodical way. So I'm looking at the single digits, the leaves. I see an 8 and a 2 in that row. I can cross these off so I don't do them again. So I can keep track of them like that. I see a 9 and a 7. Right, cross those off so I don't count them again. I see a 0 as my leaf. Cross that off, and then I see an 8 and a 3. Okay, so I circled 1, 2, 3, 4, 5, 6, 7 of those green numbers. 7 numbers that live in the 200 up to 209 range. And these are the 7 digits, the ones digit, those leaves that are on there. And now what I want to do, so here I just wrote them in the order that I notice them, right? But what I want to do now is write them in increasing order. Okay, so I see a 0, so I'm going to cross it off and put a 0 here. And I'll leave the commas out for now to match what the book does, but then I like the visual of commas. I don't have any 1s in this list, but I have a 2, right? I've got a 2. And I don't have any, if I had more than 1, I'd list it twice. I have a 3. All right, the next largest number I see is a 7. Then I see an 8 and another 8, so let me list them both. 8, 8, and then I've got a 9. So cross off those 8s, and then 9, and that's it. Okay. So we had 7 numbers with the that I circled in green that began with 2, 0, and so I should have 1, 2, 3, 4, 5, 6, 7 leaves here. And now we can see a little bit of why this thing is helpful. Let me shrink those. What did we have? 0, 2, 3, 7, 8, 8, 9. I just shrunk that down a little bit. I'm trying to buy myself a little more space to the right here because I know this class is going to be pretty big. Okay, so before we start comparing, let's do the next class. So now I want to look for anything that lives, starts with a 2, 1. So again, that's all numbers between 210 and 219. Any integer in that range starts with a 2, 1. So here I see 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, and almost all of them. Right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 red numbers right there. So what do I want to do? Again, I want to, so you don't have to build a list over here and then come over here. If you can get them in order, you can just do that right off the bat. But let me list them here and then look at my pool and then get them in order. Maybe it might be a little bit easier. So I see, I'm just writing down the leaf. So I see a 0, I see a 7, and I see a 5. Okay, so I took care of that first column. Now I see a 0 and an 8. Took care of that. Now I see a 2, a 0, a 0, and a 3. So 2, 0, 0, 3. Just cross it off like that. And finally an 8 and a 4. Okay. 11 red digits right there. We had 11 things circled up there, so that's good. And now I want to organize these in the same way. So let's look at this. I see 1, 2, 3, 4 zeros. Right? So I'm going to list. I'll try to keep the digits lined up. So I've got 1, 2, 3, 4 zeros. Don't have any 1s. But then, so just double checking. Don't have any 1s. I see a 2, a 3, and a 4, and a 5. And I think they all appear 1. So 2, 3, 4, 5. So let me list those. So 2, 3, 4, 5. And I'll explain why I'm trying to line them up like that. And then what do I have left now? I have a 7, an 8, and another 8. So 7, 8, 8, 7, 8, and 8. And just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Perfect. So we accounted for everything. All right. So why was I lining those up here? Because think about, if you tilt your head a little bit now, the sort of the length of this string of leaves is kind of like the height of a bar, right? So you know, this guy had 7 digits going over. Here we've got 4 more. So the fact that the leaves are extending further means that there were more. This class had more numbers inside of it, right? So just like on the histogram, that would be the tallest bar. This bar would be a little bit shorter, and so forth. This bar would be very short. And finally, the 2, 2. There's not a whole lot to see. I see that there's only one number right there. 2, 2 followed by a 1. So there's only one leaf, which is the number 1. And there we go. This is my stem and leaf plot right there. So that line was extra. That's what we've got. Okay. So this contains all the information that I've got here. The thing is, for all the, let's say these 11 numbers, right? All of these 11 numbers had to be organized. They all were 3-digit numbers, right? 2, 1, 0, and then 2, 1, 0 again, and then 2, 1, 2, right? So we have 11 3-digit numbers, so that's 11 groups of 3. If you write that all out, you're writing 33 different digits, right? Whereas here, we've got just the ones that, so we've got 11, 12, 13. We only have to write 13 digits, and it contains all the information, okay? So it's definitely more concise. It's more concise, it's organized, which this table was not. And of course, you could relist this table from lowest to highest, right, and add some sort of organization to it. But then you still have to figure out somehow, where does one class end, where does the other begin, how big is each class, how many members does each class have. Here, it's a little bit more obvious, okay? So it's pretty cool little technique right there. So again, always the way you'll do it is the leaf is always just going to be a single digit, and then the stem is however many other digits you need. You list your stems from lowest to highest, then you list your leaves from lowest to highest. You repeat them. If they repeat, that tells us the frequency. That part was similar to what we saw on the dot plot, right? So remember with the dot plot, above 200, above the number 210, you'd see 1, 2, 3, 4 dots. Above the number 208, you'd see only 2 dots. So here, the frequency that a digit appears tells you how frequent that piece of data was. Perfect. And again, this 0 means something different than that 0 because this is 210, so 210. This is 200, so the number 200. Okay, so that is how we create a stem and leaf diagram. There's a question on the homework. It's a little bit vague. That asks, it says, it's question 3, and it says something along the lines of, what if you've got a stem and leaf diagram that's only moderately useful? And that's subjective, moderately useful. How can you fix it to whatever, make it a little bit more useful, make it a little more pleasing to the eye, or draw other conclusions? So in other words, now I know that this is the largest class, that's the next largest class, and so forth, okay? So one way, there were 10 potential digits that could go in any class, meaning that the leaves, if they're single digits, it could be a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? So there's 10 different digits that we've got. So you could have up to 10 different answers in here. This one, the 210s, this class, there's a lot going on right there. Maybe too much for me. Maybe I want to split these categories or these classes up a little bit more. And so that's what question 3 is asking all about. And the trick is, though, so that's, you've got 4 options there, 4 multiple choices. If you're going to split them up, you need to split them up into equal-sized sort of subclasses. Okay, so one option that I could split this up, stems and leaves. One option, and this is one of the choices that you'll see, and I've learned from different students that the choices may be in different order, so it's not everybody's A is not the same as everybody's B. Let me draw 2 rows for each stem. 19, 19, 20, 20, 21, 21, 22, 22. Okay? Because maybe I'm thinking, especially with this row, there's a lot going on there. That's a lot to look at, a lot to take in, and so I'm going to split this up. So what I'm going to do here is, let's start with the 21 leaves. I'm going to list, in this one, I'm going to list any digit that goes from 0 to 4. So I'm going to list, if the ones digit, if the leaf is a 0, 1, 2, 3, or 4, right? So 5 different digits can belong in there. Then they're going to go in this first row right here. So let me list 0, 0, 0, 0, 2, 3, 4. Okay, there we go. And now what I'm going to do in this one is list the leaves that are 5, 6, 7, 8, or 9. Right? So same amount of potential digits that go in there. And that's important. 5, 7, 8, 8 is what I have. So I will list those 5, 7, 8, 8. And there we go. Okay? So what does this tell me now that the original plot didn't tell me? This one makes it more visual that now I still know that there were 11 entries in the 210 to 219 range. But this shows me that most of those entries are more towards 210. Right? There are fewer entries on the higher end of that bracket and more entries on the lower end. So a little bit more detail is shown here. It's a little bit more to write, but a little bit more detail. For this one, I want to do the same thing. So anything 5, 6, 7, 8, or 9 is going to belong in the second category. 0, 1, 2, 3, or 4 is going to belong in the first category. So I see 0, 2, 3. The first row, I should say. Or category, I guess. Classes is what we've broken these up into classes. And now 7, 8, 8, 9. All right. For this one, there was only one leaf. So that 9 is 5, 6, 7, 8, or 9. So that lives here. And I put nothing there. And with nothing, I don't write a 0. I just leave it blank, right? And now 2, 2, 1, that lives in the first row. And then 0, 1, 2, 3, or 4s would live in the first row. 5, 6, 7, 8, or 9s would live in the second row. But there are none. Okay? So we've got that. So we're just spreading out the data a little bit more. So which is better, which is worse? It's really subjective. It depends on what you're trying to do with the data. So this one, you have fewer rows, so less concise, but maybe not as visually descriptive as maybe this one is. Okay, so there we go. So back to that question 3 on the homework, it's asking, they're going to give you they're going to describe 4 methods of splitting them up. And I basically told you one of them right here. I described one of them that they do there. The thing is, you want the range, not that the size of how many pieces live in there is based on the data. So that's different from one data set to the other. But what you want to do is make sure that the size of the classes are the same. So we had groups of 10 originally, right? The digits could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so what we did was split those 10 potential leaves into 2 groups of 5. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So as long as you've got 2 groups of equal, or as long as you've got some number of groups of equal size, that's okay. So without giving too much away, one of the options maybe if you've got 10 digits, maybe you can split those up in a different way. If you find yourself saying like 0, 1, 2, 3 is going to be one class, and then 4, 5, 6 is going to be another class, that doesn't seem good because I don't know if my fingers are translating. Let's say 0, 1, 2, 3, right? So I've got 4 digits that would belong in one row, 5, 6, 7, or 3 digits that belong in another row. Those are different sizes. Not good. So you want to reject, or you're not going to select those options, but the ones where it's evenly split. As far as the edges, the upper and lower limits of the range, that's what we're looking for. Again, it doesn't matter how many of the data pieces actually live there. That's just dependent on the data. All right. So there we go, stem and leaf. Fun topic.